expand sine x squared as a series of ascending powers of x. Solution. Now, for us to expand sine x as a series of ascending powers of x, we shall apply the MACLAURIN'S series, which states that f of x is given by f naught plus x plus x f of naught prime plus over 2 factorial plus over 3 factorial plus those are f naughts plus over 5 factorial plus it continues like that. So this is the MACLAURIN'S series. So as you can see, the powers of x are increasing. You have x raised to 1, x raised to 2, x raised to 3, x raised to 4. It continues like that. So from this equation, what we are saying is that our f of x equals to sine x squared. Now, so we shall be required to get these constants. Get those constants. So once we get them, we simply come and insert them in that formula. Now, so we need to get the derivative of sine x for us to be able to get these constants. So, but before we can get the derivative of sine x, we need to change sine x into its double angles. We all know that cos 2x is the same as cos x squared minus sine x squared. And then we have another identity, the fundamental identity of trigonometry, which says that sine x squared plus cos x squared equals to 1. Now, if I want to make cos x squared the subject, cos x squared will be equal to this cross to the other side, so it will be 1 minus sine x squared. So what I'm going to do, I want now to substitute this with 1 minus sine x squared. I want to express cos x squared in terms of sine x squared. Therefore, I replace this by that one. So when I do that, so here I have cos 2x equals now 1 minus sine. Then I have now minus sine x squared. So the equation becomes 1 minus 2 sine x squared. Now I can rearrange this equation so that I have cos 2x, 1 comes on this side, to be minus 1 equals to minus 2 sine x squared. Now, to do away with this negative sign, I multiply through by negative 1. So this equation changes into 1 minus cos 2x equals to 2 sine x squared. Now, if I want to remain with sine x squared, I make I divide through by 2. Therefore, sine x squared will be equal to a half into 1 minus cos 2x minus cos 2x. So remember, this is now sine x squared is given by that. Therefore, what we are saying is that our f of x equals to, now when you open the bracket, it will be a half, then minus a half cos 2x. So now we are going to get the derivative of this rather than sine x squared. Now we shall now start getting the constants. So from here, the first step, we shall put x equals to 0 in that equation. So when we do that, this equation becomes f of naught equal to a half minus a half cos 0. Cos 0, because we are saying x is 0, so you take 0 times 2, you get 0. So we have cos 0 there. So this equals to a half minus a half, because cos 0 is 1. So we have a half minus a half. Therefore, f of naught equals to 0. So we have gotten that it's 0. Then we move on now to get the f of naught prime. How do we get f of naught prime? We differentiate this equation. So our f of x prime will be equal to, when you differentiate a constant which is a half, you get 0. And then you want to differentiate cos 2x. This cos 2x. So for us to differentiate cos 2x, we shall apply chain rule. Let us say let y equals to, I want to deal with this one, y equals to cos 2x. If y equals to 2x, then I will let u equals to 2x. Therefore, this equation now becomes y equals to cos u. Now 2x is u, so you substitute this one by u. So I have y equals to u. Then you differentiate this equation y with respect to u. So you have dy du equals, now this will be minus sine u. Then you differentiate u with respect to x. Here you have du dx, which equals to 2. When you differentiate this equation, you get 2. Then we have the chain rule. Chain rule is given by this. Dy dx is given by dy du times du dx, which equals to, our dy du is negative sine u times du dx, which is 2. Therefore, this equals to minus 2 sine u. But what is u? U is 2x. So this equals to negative 2 sine 2x. Therefore, when you differentiate this equation, we are saying, of course, we have this will be 0 minus a half, then this one dot minus 2 sine 2x. Negative and negative will be positive, then these two will cancel that, so we remain with sine 2x. So I can rub here. So we are saying that f of x prime will be equal to sine 2x. So once we get this, we now put put x equals to 0. Therefore, our f of naught prime will be equal to sine. Now x is 0, 0 times 2 we have 0, so we have sine 0 which equals to 0. So we are saying, therefore, our f of naught prime equals to 0. So that is 0. How do we get f of naught double prime? Differentiate this equation. So we have f of double prime will be equal to, now here when you differentiate sine 2x, here we shall have, you again apply the chain rule here. So when you differentiate sine 2x, we shall be able to get 2 cos 2x. Shall be able to get 2 cos 2x. Then we put x equals to 0. Therefore, here we have f of double prime naught equals to 2 times, here it will be cos what? Because this is 0, 0 times we have 0, cos 0 is 1, therefore times 1. So therefore f of double prime naught equals to 2. Where is it? That is 2. So we now move on to get f of triple prime. F of triple prime, we differentiate this equation. So we have f of triple prime, this when you differentiate cos 2x, we shall get, of course we have these 2 times, when you differentiate cos x, we get when you differentiate cos x, here when you differentiate sine, we have that. So when you differentiate, this was sine, you get, so when you differentiate cos 2x, you get minus 2 sine 2x, which equals to minus 4 sine 2x. Now we put x equals to 0. Therefore, our f of triple prime naught will be equal to minus 4 dot 2 times 0 is 0, sine 0 is 0. So this equals to 0. So what we are saying is our f of triple prime equals to 0. So that is 0. We need now to get f of naught raised to 4. So for us to get that, we now differentiate this equation. Let me wrap here. Differentiate this equation. So we have f of, so when we differentiate negative 4 sine 2x, we shall be able to get, of course we have negative 4 dot, when you differentiate sine you get cosine, so here we shall have dot 2 cos 2x. So this equals to negative 4 times 2, negative 8 cos, now cos 2x, and we put x equals to 0. We put x equals to 0, therefore we have this equals to negative 8, because 2 times 0, 0, cos 0 is 1, so we have negative 8. So this is negative 8. So we move on now to get f of naught raised to 5 f of x. So we differentiate this equation. Differentiate this equation again. Differentiate. When you differentiate this, you have 8 dot. When you differentiate cos 2x, when you differentiate cos 2x, we get minus 2 sine 2x. This equals to 16 sine 2x. 16 sine 2x. And then we put x equals to 0. So we have this equals to 16.0, which equals to 0 because 2 times 0, 0 sine 0 is 0. So we are saying that this one is 0. So we can now get f of naught raised to 6. Up here. So f of naught raised to 6, we differentiate this equation. So so when you differentiate, so we have 16. So when you differentiate sine 2x, when you differentiate sine 2x, we get dot, it will be 2 cos 2x. So this equals to 32 cos 2x, and then we put x equals to 0. Put x equals to 0, therefore we have this equals to 32. Because this is 0 times 2, you get 0, or 0 is 1, 1 times that 2, we have 32. Like that. And the process continues, so we can get f of x raised to 7, f of x raised to 9, f of like that, and then you come up with the sense. But for meantime, we can stop there and then see how the pattern of the series. So we can now say that, of course, our f of x was sine x squared, so we have sine x squared will be equal to, now this is 0, this is 0, here we have 2, so we have 2 x squared over 2 factorial. This is 0, this is minus 8x raised to 4 all over 4 factorial. This is 0, this is 32, so we have plus 32 x raised to 6 all over 6 factorial, and it continues like that. So this equals to 2 factorial is the same as 2 times 1, so 2 divided by 2 here. So here we remain x squared minus 8 x raised to 4 all over 4 factorial is the same as 4 times 3 times 2 times 1, which is the same as 24. Then plus 32 x raised to 6 all over 6 factorial is the same as 6 times 5 times 4 times 3 times 2 times 1, like that. So this equals to, of course, it will be x squared minus 8 here 1, 8 here 3, so minus x squared over 3, x raised to 4 over 3, then plus, this is 32, 4 here 8, 4 here 1, 2 here 1, 2 here 4, 2 here 3, 2 here 2, another division, and so we remain with the 2x raised to 6 over 3 times 5 times 3, that is 45. Therefore, at this point, we can say that the series for sine x squared is x squared minus x raised to 4 over 3 plus 2x raised to 6 over 45. and it continues like that. Thank you for watching and listening.